Before I start stuffing my sound, I wanted to show you this other thing that we had put together. This is a button box. This is a uh, three position, two pole button, so that the transformer in energy is wired into the main post, and then you've got a pair of posts here and a pair of posts here, and that in one direction goes one way, and the other direction these wires are twisted so that it goes in reverse. So I thought I'd show you. This is a reverse switch if you have DC control at the track. So this power would be the track power. It would not be in the tender. It's an idea to put some kind of a relay in here, but we're not done. We don't have it yet. So if you're running DC and you turn this up a little bit, oh no, you got to put it in gear. All right, let's go one way. Oh, too fast, too fast. Let's see where it's going. Oh, it's in reverse. Okay, so we're going in reverse. And you can slow it down, stop, and now you're in forward. See that? Now if you're really dumb, you can do it real fast. That's hard on stuff, but you can. So ideally, you'd want to do this and then go there. Ideally, what you would do is ramp it down until it stops and then change direction. Okay, so this is how you get direction when you have DC. Now, my next question someone asked me was, what if this was an AC motor and you had this wired? Would that do it? I don't know. Very good question. I've tried it manually and I couldn't get it to work. But I can try it again, because the AC motors are designed to run in fields and brushes in series, and it's really hard to change the brush or the field flow without changing the other. It's hard to change one or the other. This being DC, these are magnets in the field, and all you're changing are the brush polarity, so that's easy. But if I try to run the fields in parallel and not change them and then change the brushes, for some reason when the armature and the fields are in parallel, the engine runs really hot. It's not made to do that for some reason. I don't know what's going on, but it just doesn't. That's why we have that weirdo solenoid gizmo, where you just stop all the power and it ratchets, and then you start the power and then you stop it and then you ratchet and then it goes the other direction. It may be. I can find a relay or a switch like this that when it loses power, it indexes to the next. I don't know. Okay, haven't looked, don't know. But an AC switch is a challenge. But if we put everything on DC to the track. Well, even if you have AC to the track and then you come out DC, that's the other problem. I can do the rectification, right? This is AC to DC. My problem was I'm getting, when all these little devices, 5 volts and this and that, turn off and on and do their thing, they cause a ripple, and the engine actually changes speed. We don't really want to have smoke and you hit a button for sound and the engine goes. Rrr. We really want it to be consistent. So I've got this, put it together, haven't tested it, but it's a 2200 microfarad capacitor. Obviously it's big, okay? This stores energy. And what happens is when you go from AC to DC, you've got a bunch of little humps. And then when you start parsing that out, those humps become visible in the operation. So you have a DC current going like this. And what this is, like a big accumulator, think of it as a shock absorber for energy, and it can store up energy so that if you have a down, it can fill that in. So it gives you a more level power. It gets rid of what we call ripple in the DC. So I'm hoping if I put this in, I can have a smooth DC operation so that all the technology, even if you want to run your blunderbuss on the track, you'll still have the power, smoothness of the power to operate the digital stuff. I know this looks, I'm looking at it through the camera here and it's just a mess. It's just cables everywhere. How does it work? Oh, well, you saw it, right? We got reverse, now we have sound. We're cooking. We are cooking. Okay, back to work later.